projector. We are now recording. Close out my calculator. Okay. We'll get started from the current lab in just a moment. Maybe. PowerPoint's doing really strange today. Strangely. Okay, there we go. All right. First, these announcements you've heard ad nauseum, probably. Coming up 1 week from yesterday, next Wednesday, is the Lawson State College Transfer Fair Days 2020. This will be from 9:30 to 11:30 on the Birmingham West Campus, the academic building, which is B Hall. They'll set up tables all up and down that long hallway. All these, a bunch of these schools will be at those tables. Just about every university and four-year college in the state of Alabama, many from Georgia, Mississippi, Tennessee, Kentucky, just all over the place. A bunch of colleges have been invited. Whether they all come, I'm not sure. Okay? Then on Thursday, 1 week from today, next Thursday, from 9:30 until 11:30, they'll be on this campus, in this building. They say somewhere near the cafeteria. They say in the cafeteria, but I just don't think they'll fit. And I think that's going to be when breakfast is ending and lunch is beginning. It just seems like a kind of a bad time to be in the cafeteria. So I'm guessing they mean in the faculty staff dining room, which is right next to the cafeteria. Plenty of room in there for tables, and may not be enough for everybody, but then they can spill over either to the cafeteria or the hallway or the front desk area, anywhere there. But they'll be around. You can just ask around and see. Same schools will be invited. Whether they all come, we're not sure, but hopefully they will be a good representation there. Please go by and see, even if you're not quite ready to transfer or not, you think you already got it nailed down, find out. See what they offer, see what kind of questions they ask, see what they're looking for. It's well worth your effort. Okay, and you want to be a poet this summer? Well, this is the power optimization of electrothermal systems. Not quite the kind of poets you were probably thinking of, but it's a great 10-week summer internship for research experience for undergraduates in the fields of mechanical, electrical, and materials engineering at University of Illinois, University of Arkansas, and Howard University. Fantastic learning experience that costs you basically nothing. They pay you to go to it. $5,000 stipend. They provide free housing, so you don't have to pay for any housing. Usually the free housing comes with a meal card, so they feed you for 10 weeks. And they provide airfare there and back, one round trip airfare ticket. So, boy, what an opportunity. Try to, if this is anything near your field, try to explore this one. There are other REUs out there. That's research experience for undergraduates. You can check those out as well. The email said February 15th is the deadline. That was a little suspicious because that was a Saturday. But the brochure said February 17th, which is a Monday, which makes more sense. Get your application in early so you don't have to worry about either one. Now, I just happened to notice something I failed to do from my last class. Hold on just a moment. And let me get that done. I had my presence here, but not my absences. Okay. And Ja'Cory, right? Yeah. Now, this other announcement, I don't think affected anyone in this class. I can't say that for sure, but I don't think it did. But it's something you need to know about. And in case it did affect you and I just skipped it or didn't notice it, it sort of affected one person, but I think it was taken care of. Well, I don't know. Every day, at the end of the day, I do put attendance in the system, okay? Monday, I put it in, no problems at all. Tuesday, when I went to put it in, I started running into some difficulties. One student in my first class, when I went to do attendance, it indicated I needed to do it for the whole term. And I've been doing it every day. So I went to the first day of class, clicked on that. One person who had been here, I put his attendance in, had no attendance. So I had to put it in. And I had to do that for every class from the beginning of the term, that one student. Then when I got to last Tuesday to put in the attendance for the whole group, there were 2 people missing. So these 2 things put together indicated to me they had removed all the unpaid students. So if you, by chance, or if you know of someone who may not have completed payments, the odds are that person has been removed from their classes. And I would think you'd be able to tell by trying to log into something. And if you can't get into your student suite or into your class on Blackboard or something like that, that may indicate you are missing a payment or something. Now, this has happened a few times before, that someone's been on, say, a scholarship or something like that, and they pay tuition, but they don't pay all the fees. But you didn't realize they didn't pay all the fees, and you may only owe your $10 or $11 insurance, and yet they kicked you out of class, okay? You don't want that to happen. Take care of it, get things squared away. So if you hear anyone griping or complaining or saying, what's going on here, check with them, gently and say, are you sure everything's covered? Go by cashier's window, financial aid, financial services, or registrar's office somewhere and find out what might be going on, okay? Because it did affect people in certain classes. I think it also affected one person in this class. No, that was the second issue. Okay, the second issue was on Wednesday, I guess it was. I saw that I had missed something earlier in the week, okay, or earlier in the month, first of the month. I was supposed to have done a no-show report. Well, the no-show is if someone had paid for a course but never attended, okay? And I was supposed to report it on that. So I did. I did it Wednesday. There was one person in this class who was, I think if I had done it when they wanted me to do it, he would have been a no-show. But he had shown up after, they sent the thing, and so therefore it had him no dates of attendance, but he had been here at least twice. So that was the one that showed up there. So number one, they removed all the students who hadn't paid, and number two, they were looking for students who had paid but had never attended. They're going to remove them as well. So, but I did not put them as a no-show, so hopefully they will not remove him from the class. Okay. So anyway, those were the two events that happened that had some impact on this class. And you may hear classmates or friends or other people who say, hey, what's going on here? Let them know what could be going on. All right. Any questions? Academic? Yes.
Did you ever pass out a test, take home?
Yeah, I passed it out last time. Okay, can you get it at the end of class? Okay. Is that all right? Okay. All right. But before you leave, get it. Okay. Now, I gave the first test after 4.4, and we finished that last time. Today, we're still in Chapter 4 of trigonometry, but we're starting in 4.5. We're going to be talking about the graphs of sine and cosine functions. 4.6 will cover the other functions, but 4.5 will be graphs of sine and cosine. So our objectives here are to sketch the graphs of the basic sine and cosine functions. We're going to introduce a few terms here and use those to help sketch graphs. One of these is amplitude. The other is period. Okay? And these will also help us sketch graphs of sine and cosine functions that aren't the basic ones that have been modified somewhat. Then we'll sketch translations of the graphs of sine and cosine functions. That could be horizontal and vertical translations. And by the way, just for your information, the amplitude and period these are translations. Amplitude and period are your non-rigid transformations. They don't call them that here, but if you remember that from your pre-calculus algebra, that's what amplitude and period affect. The translations just shift them right, left, up, or down. Okay? And we'll use the sine and cosine functions to model some real-life type data. Okay? Be a fun exercise. So let's look at the basic sine and cosine curves. In this section, we'll study techniques for sketching the graphs of sine and cosine functions. The graph of a sine function is called a sine curve. The graph of a cosine function is called a cosine curve. Together, and they don't say that here, but you'll run into it in future courses, sinusoidal. That anything that has the basic shape of a sine or a cosine is often called the sinusoidal curve. Don't worry about it here. It's a hard word to say or spell. All right. In this figure that we have here, it's in your book as well, the black portion of the graph represents one period, also called one cycle of the sine curve. Now, what do we mean by that? Well, the sine curve does this. Forever and ever and ever and ever and ever. In the other direction too, it just keeps going up and down and up and down and up and down and up and down forever. So, it follows the same pattern over and over and over again. Now, they haven't said it yet. They will a little bit later. This is what we call a periodic function. That's why they call them sinusoidal curves, periodic functions. Okay? Why do they call it periodic? You have one period that repeats itself over and over and over in both directions. That's a periodic function. Okay? The period is the smallest unit that repeats itself. Okay? Now you might say, but wait a minute, I see a 0 here, a 0 there, and a 0 there. Wouldn't this be a period? No, because the things in between the zeros are going in opposite directions. But once you get here, you see everything flows in the same direction. Once you get here, everything flows in the same direction, over and over and over again. So the gray portion of the graph indicates the basic sine curve repeating indefinitely left and right. The darkened part shows just the primary period, one cycle or one period of that function. There's your sine curve. Now they put in some of the other values. I usually don't. Okay? Angelica is here. Okay? I'm pretty sure the announcement I made earlier didn't directly affect you, but you may know someone that did. Tuesday of this week, when I was entering attendance at the end of the day, I found out they had removed all students who had not paid yet. So if you hear any friends or classmates or something say, hey, I can't accept blah, 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 the odds are they've been removed from the class because they didn't pay. I think they are allowing students to go and pay, and then they'll put them back in the class. Okay. Then also, and this doesn't affect anyone here, almost affected one person, but he's not here now. They also are in the process of removing any students who never showed for a class. A paid student who never attended, that would be a no-show, and they'll remove those as well. So they're into the purging process a little early this term. Sure, most schools do it before now, but Lawson always drags its feet, but that's happening now. So here are a few of the key points for sign. The sign of 0 is 0. The sign of pi 6 is 1/2. The sign of pi fourths is square root of 2 over 2, which is a hard thing to plot. Square of pi thirds is square root of 3 over 2. Sign of pi halves is 1. Sign of 3/4 pi is root 2 over 2 again. Sign of pi is 0. Sign of 3/2 pi is -1. Sign of 2 pi is back at 0 again. This is one period of the sine curve. Now, most of the time, I don't plot these in between. I usually do 0, pi halves, pi, 3/2 pi, and 2 pi. That will do it for me because I know these are the zeros, the max, and the min. That's all it takes for me. I'll just draw the graphs. Probably not accurately, but as well as I can. Notice the normal period is 2 pi. That's the time to go from this 0 to that 0. You don't count that as a period because the function's increasing here, decreasing here, increasing here. So that's the period. It has to be not only the same value, but also going in the same direction. So that's what makes 2 pi the period. Does that make sense? So there's your basic graph of the sine function. Remember, sine of 0 is 0. Sine of pi halves is 1. Sine of pi is 0. Remember, the sine function has its zeros at the whole pi's and has its max and min at the half pi's. Okay. Now, once you get that done, then the cosine function. Now, just a quick glance, this looks a lot like the sine function, doesn't it? Okay? Now, things I didn't mention, let me go back and mention them. The range of the sine function is -1 to +1, -1 to +1, -1 to +1, -1. Never gets outside there. Always between plus and -1. Okay? Both directions. The range is always between that. The period is 2 pi. Okay? That's the sine curve. The cosine curve, like I said, looks very similar. Its period is still 2 pi. Its range is still plus or -1. The only difference is it shifted pi halves. Okay? Because this for the sine function was over here. This for the sine function was over there. This for the sine function was over there. Everything shifted pi halves. Okay? So, remember this. Here are the key points for cosine. 0 is 1. Pi halves is 0. Pi is -1. 3/2 pi is 0. And 2 pi goes back at 1 again. That makes the period 2 pi. And that's the cosine function. Remember where they begin. Okay? Does that make sense? All right. Now, trying to find this slide. Yeah, there it is. Okay. This is still on page 297. We know that the domain of the sine and cosine function, all real numbers. Every value has a value. Okay, it keeps repeating, but the domain is all real numbers. The range, plus or minus 1, plus or minus 1. Always in between those two. Okay, the interval -1 to +1, including the plus or minus 1. Each function has a period of 2 pi. Do you see how this information is consistent with these graphs? They've shown the period, they've shown the range, they've shown the domain goes on forever. Plus or minus infinity. Okay? Hopefully the answer is yes. Any questions on it? Okay. Note that these are still the bottom of page 297. Those two figures, the sine curve is symmetric. Oh, yeah. Let's go back and look. The sine function is symmetric about the origin, meaning what kind of function is that? Even or odd? Odd. This is odd. Cosine is even. Sine is odd. Because sine of negative x is the opposite of sine of x. Okay, so it's going in opposite directions. So this is reflected across the origin. That means it's an odd function. The cosine is reflected across the y-axis. That makes it even. The sine of negative x is exactly the same as sine of x. Okay? Always. So sine is an odd function, cosine is an even function. I think we had that before as well. And what it means to be odd, it reflects about the origin. It means to be even, it reflects across the y-axis. Okay. All right. Those properties of symmetry follow from the fact that the sine function is odd, the cosine function is even. Exactly what we said. Now, I don't know what does this. It's weird. I have no idea why this is doing this. Okay? Nope. Yeah. I have an idea. This room seems worse. Let me get where we are. Okay. This is the one we left off on. Okay. I noticed this at the end of the last class. My power light here on my computer is just flickering all the time. I want to say this never happens at home. This room is the worst. A couple of other places I've been in, it happens. It doesn't happen every day or every time, but it seems to be doing it now. I don't know if it's the room. I don't know if it's just the time of day. I don't know if it's the aura. I don't know what it is, but it tends to do that. So that's why we're flicking like that, or is my best guess. Okay. So anyway, that gets us through page 297. Flipping over to 298, to sketch the graphs of the basic sine and cosine functions by hand, it helps to note the 5 key points of one period of each graph. And this is what I was saying before. They're the intercepts, and that means the x-intercepts. Y-intercept you usually plot too, but basically focus on x-intercepts, the maximum points, the minimum points, and that's it. For the sine function, you have 3 in one period. The way we said that first period, you have 3 x-intercepts, 1 max, 1 min. Okay? In the cosine function, and the only reason there's 3 intercepts is that 0, 0, and 2 pi 0 are basically repeating the pattern again. So actually only one of these is in one period, the other is in the next period, but they count it as the 5th point, 5 key points. For the cosine function, since you start at the 0.01 rather than the origin, you have a max, a 0, or a intercept, a min, an intercept, and then another max. That max is the same as this one. It's just this one begins this one, that one begins the next one. Okay? But they count them as 5 things. Frankly, I do multiple periods. Okay? They always follow the same pattern. Okay? And if you get those, don't worry about these in between. I can't figure out where they are anyway. Just get the max, the mins, and the intercepts, x-intercepts. So your y-intercept is the max here, the y-intercept is the x-intercept here. So you're doing y-intercepts too, but you don't do them specially. You do the things on the x. Does that make sense? Okay. Notice sine starts with origin, cosine starts with +1. Okay. So, sketch the graph of, now here they cheat. Okay. They throw in something they haven't told you about. They put in, and later we'll call this the amplitude. Okay. Back in pre-calculus algebra, you called this a non-rigid transformation, a vertical stretch. Okay, that's what you're doing here. But we're going to take it and go with it. They've given us an interval that goes from -pi to 4pi. So that covers way more than one period. So let's sketch the graph. Okay. Now, I'm going to start it by doing this. I'm going to start it by saying, let's sketch, say, what we used to call the parent function. Let's first graph y is equal to sine x. Then we'll deal with 2 sine x. Is that okay? Because before this is how we did it in pre-calculus algebra. So I'm going to draw my horizontal axis here. Okay? And it's going from -pi to 4pi. So it's -pi, 0, pi, 2, pi, 3 pi, 4 pi. So I've got at least 6 points on it. So let's do 1, 2, 3. That's probably too many, but let's just assume that's about what we got. Okay? I'll put my origin here, my y-axis there. This will be my -pi. This will be pi, 2 pi, 3 pi, and 4 pi. Okay? That'll cover my interval. Okay? Now, most of the time, sine goes from -1 to +1. But this 2 here is going to require us to go -2 to +2. You'll see that in just a minute. Okay? But let's first graph this function. Y is equal to sine x. Where does sine start? At the origin. And at pi halves, remember, for plotting purposes, I like pi halves, pi, 3 halves pi, 2 pi, 5 halves pi, 3 pi, 7 halves pi, 4 pi. Going this way, -pi halves. I'll go on and do -3 halves pi, though it didn't ask us to, and this goes up to -2 pi. They didn't ask for that either, but since I had them marked, I'm going to do them. Okay, sine, the normal sine function starts at 0. Where does it go at pi halves? Up to 1. Then down to 0, down to -1, up to 0. Up to 1, down to 0, down to -1, and up to 0. And keeps on trucking. Here it goes down to -1, up to 0, up to +1, down to -1, and keeps on trucking. So, the sine function does something like this. And I try to encourage students to always make these curved. Some of mine aren't as curved as others, but they're always smooth curves. There's a tendency to sort of make them jagged. Don't do that, okay? Make sure they're nice, smooth curves. They always are, okay? Now that was that function. What this function does to it, for every value of this function, is doubling it, right? So when you double zero, what color do you want this function to be? Pick a color, any color. Yellow? Oh, something that's hard to see, huh? Okay. This will be fine. Okay. So if you double zero, you're still at 0. If you double 1, you're at 2. Double 0, you're still at 0. Double -1, you're at -2. 0, -1, 0, -2, 0, and so on. Here, going in this direction, -2, 0, 2, 0, and so on. So your function they ask us to do is something like this. And it's even harder here to keep from making them peaked. Now, of course, my scale isn't really good either. Always have them smooth. It's real tempted to make them jagged. Don't make them jagged. Keep them smooth at the maximum end. So there is the graph of the function from -pi to 4 pi. I did an actual one here because I had it drawn, but there's -pi to 4 pi. It keeps going past 4 pi, it keeps going past -pi, as you see here. Does that make sense? Any questions? The fact that they're periodic means you just draw them period after period. Okay? Now, there is a checkpoint. Please review the checkpoints. All right. That was example 1. Now, let's see how they did it. Okay. Let me erase mine, even though that's so pretty. Okay. Note that y is equal to 2 sine x is twice sine x. That's exactly what it means. Indicates the y values for the key points will have twice the magnitude of those for y is equal to sine x. That's why I did y is equal to sine x first. Now, here's how they do it, and it's exactly what we did. Divide the period 2 pi. We know the period for sine is 2 pi. Divide it by 4 equal parts. I did it without telling you, but they're telling you. Always find the period, divide by 4 equal parts. So 2 pi divided by 4 is what? 2 pi, whoops, let me get out of my yellow, back to black. What's 2 pi divided by 4? Pi halves. So that's why I use pi halves as my basic division line. Okay? Always take the period, whatever it is, divide by 4, and that gives you your key points. Okay? And then identify, because it's a sine function, you start at 0, 0, and then go there. If it were the basic sine function, that would be a 1. Since it's twice that, it's a 2, 0, minus 2, 0. Once you got those increments here, 0, pi half pi, 3 half pi, 2 pi, that's what this tells you. Then put in the 0, max 2, 0, min, -2, 0. The intercepts are at 0. Okay. Got it? All right. By connecting those key points with a smooth curve, that's why you don't make them jagged, smooth curve, and extend the curve in both directions over the interval from -pi to 4 pi. Here is the graph, and that's what we showed too. Here is that parent function, y is equal to sine x, okay? And then you just double every value here. Double 0 is 0, double -1 is -2, double 0 is 0, double 1 is 2. Everything is just double. And if you make nice smooth curves in between, you'll see every value here is double. Okay, everything is double. Does that make sense? Now, let me warn you ahead of time. The next test is going to be, in one sense, the longest test because you're going to have pages of graphing, okay? It's really going to be the same length as the test I gave you last time. Did you get the test? Okay. That you'll get not coming up. It's going to be about the same length as number of questions, but the first, I think, 9 questions are all graphing questions. So it's going to take you multiple pages to do that. All right, so let's go to amplitude and period. Believe it or not, we just hit our first amplitude. At 2, that was an amplitude. In the rest of this section, we will study the graphic effect, not like the graphic novel, but graphic effect of each of the constants A, B, C, and D on the equations in the form. And I don't know why they do it this way. There must be a reason. I would have put the D plus D at the end. They put it at the front. Makes no difference, but it just seems weird to have A sine BC minus C, BX minus C, but then put the D over here. Why didn't they do plus D out here? I don't know, but they did. I think the reason may be they didn't want you thinking that's part of the sine function. So they put it in front so you know it's not. But we'll do the same with cosine. Now right now we're only going to deal with A and B. C and D will come later. But if you think back to your pre-calculus algebra, A gives you a vertical stretch or shrink, B gives you a horizontal stretch or shrink. C basically gives you a horizontal shift, even though it's not quite correct now, and D is just a vertical shift. So whereas in pre-calculus algebra we dealt with the shifts first and then the stretches and shrinks, in this one we're dealing with the amplitude and period. That's not the period, but it leads to the period first, and then we'll deal with the shifts. All right, David decided he would join us today. Good deal. Okay. So, right now we're going to start with A's and B's. The constant factor A in either this form, y is equal to ax plus a sine x, so we're not dealing with the B's, C, or D's, just a sine x, okay? Or, okay, oh, okay, they keep on coming, okay? Carolyn, right? All right. Now, I don't think either of you were affected by either, but just to let you know, as of Tuesday of this week, it appears that they removed all unpaid students from the rolls. As I said, I don't think it affected anyone in this class. As of Wednesday of this week, they had me, I should have done it earlier, put in no-shows. We almost had a no-show, but he showed up right about the time that they were asking for no-shows. So that didn't affect anyone. What a no-show is, people who have paid for the course but never attended, they're removed from the course. And the non-paid students were removed from the course sometime between late Monday and early Wednesday, sometime on Wednesday, because Monday wasn't affected, Tuesday was. So sometime late Monday or early Tuesday, they put in, they removed unpaid students. So if you know of anyone who says, hey, I can't access my web suite or whatever, ask them, hey, you might want to check on your payment, to see if everything's covered. Now, sometimes they'll do it if you got all your tuition and fees paid for but forgot to do your insurance or something like that. They'll kick you out of the class because of that $10 or $11. It's kind of nuts, but they will. So please, that's what's going on. Okay. So what we're dealing with here is the constant factor A, and y is equal to a sine x, and it would also be for a cosine x, acts as a scaling factor, a vertical stretch or a vertical shrink of the basic sine curve. when the absolute value of A is greater than 1, that's a stretch. The basic sine curve is stretched vertically. And when the absolute value of A is less than 1, then the basic sine curve is shrunk. Okay? And that magnitude of A, which is the absolute value of A, is called the amplitude. Haven't said it yet here, but that's the title there. Okay? And this, by the way, is top of page 299 for those who just came in. Okay? The result this is also on page 299, middle of that paragraph. The result is that the graph of y is equal to a sine x ranges between minus a to plus a instead of between plus and minus 1. It's now plus and minus a, or plus and minus a if a is small. Okay? The absolute value of that quantity a is called the amplitude of the function. That's pretty convenient, a amplitude. That works pretty well. So y is equal to a sine x. That last example we did was y is equal to 2 sine x. That stretched the function sine x by a factor of 2. The range of the function for y is equal to a sine x now for a greater than 0 is from minus a to plus a. You've just stretched it. Or shrunk it. If a was less than 1, now it's made it smaller. So the definition of amplitude of the sine and cosine curves, they were talking sine here, now they're including cosine. The amplitude of y is equal to a sine x and y is equal to a cosine x represents, okay, so get this, half the distance between the max and the min, because you go up a and you go down a, from minus a to plus a. So the absolute value of a is 1/2 of that difference, okay? 1/2 between the max and min values of the function. It's given as the amplitude is equal to the absolute value of that a. That last example we had 2, absolute value of 2 is 2. So it went from minus 2 to plus 2. All right. And the difference between the max and min was 4. So half of that is your 2. Okay. Now, they skipped example 2, didn't they? This jumps over to the top of page 300. It seems like a dumb thing to have skipped example 2, but they did. Okay. Let me erase my scratch here. And we'll use this slide to do example 2. In the same coordinate plane, sketch the graph of each function. Okay? The a function is y is equal to 1/2 cosine x. And b is equal to, y is equal to 3 cosine x. Okay? Now, actually, I would suggest you do this first. Graph your parent function. Y is equal to cosine x. Do that first, then come back and do the other two. So here's going to be my vertical axis. Here's going to be my horizontal axis. Okay? Now, they didn't say how far to go, so I'm going to go just so far in each direction. Let's just do 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5, 6. Positive 1, 2, 3. Negative 1, 2, 3. Okay. I think you'll see why I did this in a minute. Okay. Now, get used to this question first. What is the period of cosine x? You remember that? Now the period. Period is on the x-axis. What's your period? Right there it says full period is how much? How far do you go on the x-axis to get one full period? Second. 2 pi. Okay, remember? Go way back. Each function has a period of 2 pi. Sine and cosine have a period of 2 pi. Okay, it's usually the first question to look for. What is the period? Cosine x. Period is 2 pi. Now, what do we do with that 2 pi? Split it into 4 equal pieces, so we divide by 4. And what does that give us? Pi halves. Now, that's what I'm going to make my interval to be, the pi halves, because that's the interval I want to use is 1/4 of the period. So this will be pi halves, pi, 3 halves pi, 2 pi, 3 pi. I'm not going to put all the half pi. The half pi's are there. I'm just going to write them. They're hard to write. This will be minus pi halves, minus pi, minus 2 pi, and minus 3 pi. Okay? Now, what's the normal range for your cosine function? -1 to 1. But because we're going to be multiplying by 3, that's why I put 3. So I'm going to put -1, -2, and -3. 1, 2, 3. Now my y-axis should not be leaning, and I probably should straighten that out. So let's see if I can straighten it a little bit.
I know I'm late, so period is just the interval on the x-axis?
Yeah, period is the interval on the x-axis where it starts repeating itself. Okay? And yeah, that's exactly right. Okay. Now, we're going to start with the cosine, the basic cosine function. Okay? Tell me where it begins usually. Cosine. 0, 1. Okay, right there. And where does it go from there? Going to the right. Down to 0, down to -1, 0, +1. 0, -1. That's what it does. Periodic function. One period is 0 to 2 pi. Going in the other direction, it goes down to 0, down to -1, up to 0, up to +1, down to 0, down to -1. Just keeps on trucking this way. And it keeps on trucking after that too. There is your basic cosine function. Okay? That's what it is. That's the cosine function. One complete period, one complete cycle of that is from there to there. And after that, it just starts repeating itself. There's one complete cycle. After that, it just starts repeating itself. Okay? Always just repeating itself. Okay? Now, what's different about A here? What color do you want A to be? Pick a color. Red. Dark or light? Dark. Okay, I like the bright red too. What's different about the A one here? Yes, the 1/2. The amplitude is 1/2. That means it only goes not from -1 to 1, but from -1/2 to +1/2. So this is here. That stays here. This one goes to -1/2. That stays there. This is +1/2. That stays there. And this is -1/2. Going the other way, back to 0, -1/2, 0, +1/2, 0, -1/2, and 0. So the new function, the A curve here, is just like the old, only someone sat on it. Okay? You compressed it by a factor of 2. Okay? That's what amplitude does for you. Now, similarly, what color you want B to be? Purple. Okay? What do we notice about B? Say again? Yeah, the amplitude becomes 3. So it starts at 3 rather than 1, goes down to 0 still, goes down to -3 now, back up to 0 and back up to 3, then down to 0 and down to -3. In the opposite direction, it goes down to 0, down to -3, up to 0, up to +3, down to 0, and down to -3. Okay? Ooh, my drawing is not good. It's pretty pathetic. Okay. Whew, that's pretty ugly, huh? But that is now the graph of that. What's the amplitude doing? 3 was a vertical stretch. 1/2 was a vertical swing. Outlines where your period stayed the same. The cosine x is still cosine x. The period stayed the same. But the amplitude decreased for A, increased big time for B. Make sense? All right.
And that would be the answer to the question. When it be, when you just want us to graph, that was the question we had, you just want us to graph.
The question was, on the same coordinate plane, same coordinate axes, I sketched a graph of each of these two functions. I also put in, as they did in the book, the y is equal cosine x. That's just easier for me to work with. Yep. Okay. But you don't have to, but they did, and so did I. They focus on those intercepts, max, min. Of course, I do too, but I don't stop and call them that. I put in the quarter. Your intervals are going to be your quarter period. Okay, period was 2 pi. A quarter of that is pi halves. I put those in, and then I know it's going to be. Once you know where to start, after that you're going your max, min, intercept, whatever. There is a checkpoint. Please do the checkpoints. Okay. Now, oh yeah, we've already done. That was example 2, wasn't in the slide set. So let's move on to, that was example 1. So we've done amplitude. Now, this picks up with the top of page 300. The graph of y is equal to minus f of x. If you recall what that did, that reflected the graph across the x-axis. Okay? When you negate the y, you reflect across the x-axis. So whereas okay, here we have, for instance, the graph of y is coming back, I think. Okay. Y is equal to -3 cosine x is a reflection of the graph of y is equal to 3 cosine x. That's the last one we did, the b, remember? That was the 3 cosine x. So if you're doing -3 cosine x, basically what you've done is reflect this across the x-axis. So this reflects down here, this one reflects up here, this one reflects down here. Of course, the places for the intercept, they just stay there. This one reflects up here. So therefore you get reflection. Now the other way to look at that, whereas cosine x starts with +1, multiply that by -3, you're starting at -3. Okay? So you can look at it either as a reflection or just 3 times where cosine normally begins, which is +1, -3 times that is -3. Either way, they work both ways. Does that make sense? Did your amplitude change between this one and that one? No, the amplitude is the absolute value of that A. Absolute value of -3 is the same as absolute value of 3, both 3. Okay. And as I said before, that's half the difference between the max and the min. Max of 3, min of -3. The difference between that is 3 minus -3 is 6. Half of that is 3. That's another way to talk about your amplitude. To me, that's more awkward, but we'll be using it later. Okay. Now, because y is equal to a sine x completes one cycle from 0 to 2 pi, it follows that if you have y is equal to a times the sine of bx, it follows one cycle from 0 to, and this, it makes it seem like this is intuitively obvious, and it isn't, okay? What I think they should say, then bx completes the cycle from 0 to 2 pi. If y is equal to a sine x completes the cycle from x equals 0 to x equals 2 pi, it follows that y is equal to a sine bx, then bx would complete the cycle from x equals 0 to x equals 2 pi. Well, then divide everything by b, and you get 0 divided by b is 0, 2 pi divided by b is 2 pi over b. Okay. Yeah. So, where b is always a positive real number. Never make b negative. That just screws everything up. B is always a positive real number. Okay? Doesn't have to be an integer. It just needs to be a positive real number. So the period of sine and cosine functions, let b be a positive real number. The period of y is equal to a sine bx, or y is equal to a cosine bx, is given by always 2 pi divided the normal period divided by b. Okay? Now, what if b is a big number? Put it in the denominator, that makes the period smaller. So remember, anything you do to the x is backwards. Okay? If you multiply x by a big number, that's a horizontal shrink. Multiply x by a small number, that's a horizontal stretch. The a, vertical stretch and shrink, hey, if that's big, it gets bigger. If it's small, it gets smaller. B, if b is big, it gets smaller. If b is small, it gets bigger. Everything is backwards with the x. Remember that, okay?
Can you explain how everything is backwards with the x one time?
Say that
Just
again.
go through what you said again. I couldn't catch everything you said. Like how is when the x is smaller?
Not x, when b is smaller. When b is smaller, because you're dividing by b, let's just take, give me a small number for b.
3.
Okay, that's a pretty big number. Normally b is 1, okay? Let's just do 1. Okay, b3, that would be a bigger number. So you increase the b here, okay? Well, over here, your normal period was 2 pi. Divided by 3 is 2/3 pi. So now your period, rather than being 2 pi, is 2/3 pi. You divided it by 3, okay? Now, let's take the same type of concept and make b 1/3, okay? So it's 2 pi divided by 1/3, which is over 1/3, which is 2 pi divided by 1/3 is the same as 2 pi times 3 over 1. You just increased it to 6 pi. So now your period is bigger. So anything you do into the x is going in the opposite direction. Put a big B there, you're shrinking. A small b there, you're stretching. Okay? That's what I was meaning. Note that when b is between 0 and 1, in other words, less than 1, but it always has to be positive, that's why it's 0 here, the period of a is equal to, y is equal to a sine bx is actually greater than 2 pi when b is a smaller number, represents a horizontal stretching of the graph, whereas if b was a big number, like 3 like you said, that's a horizontal shrink, okay? So a big B makes a shrink, a small b makes a stretch. Everything dealing with the x is backwards. Okay. Yeah, okay. This is continuing middle of page 300. Similarly, when b is greater than 1, a bigger number, remember b's are always positive, okay? The period of y is equal to a sine bx is actually less than 2 pi because you're dividing by b, making it a smaller number. Represents a horizontal shrinking of the graph y is equal to a sine x. When b is negative, don't do it, okay? What a negative b does for you, because sine is an odd function, sine of a negative x is negative sine of x, and cosine of a negative x is the same, because cosine is an even function. So you just use it to rewrite the function, then you deal with the new one you have, okay? So that's why we don't let b be negative, because all that does is it does one thing to sine and another thing to cosine. Actually does nothing to a cosine. So here's example 3. That's what I was making sure they didn't skip this one. Sketch the graph of y is equal to sine of x over 2. Okay? Now here is what I suggest you start doing. You don't have to do this if you don't want to. This is just my dumb way of doing it. Okay? I always start with, what's my A? Oh, here we're still purple, aren't we? Let's get back to black. Okay? What's your A here? If you don't see a coefficient, you assume it's 1. So your A is 1. So you're going from plus and minus 1. Okay? It's a sine function. What's your B here? It's what? I can't hear you. Not x over 2, 1/2. It's the coefficient of the x. So 1/2 is the coefficient of the x. X is your variable. Don't include that in the b. Okay. So this implies the amplitude is 1. Absolute value of a. Now this affects the period. How does it affect the period? Period is always your basic period for sine is 2 pi divided by b, okay, which is 4 pi. You got it. So your new period is 4 pi. Once you determine the period, what did I say before you usually do? Divide by 4. That gives you your interval. So once you determine the period, take that period and divide by 4. Okay? And that gives your interval, your x interval, to be pi. Okay. That's how I start to do the graph. Okay? Then do my axes. Okay? And I'll just tick off some points here. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5. Okay, whatever. And then 1, 2, 1, 2. Okay. Now, your amplitude, minus 1 to 1. Amplitude is 1. Your interval here is pi. So this is going to be pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Okay. Negative pi, negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi. I didn't do it very symmetric, did I? Okay? That's your interval. Okay? Where does sine begin? Your basic function here is sine. Where does it begin? Say again? Origin. Yeah, absolutely. I don't hear well. Okay? And then the first step of your interval, your first interval, it goes up to your amplitude, which is 1, down to 0, down to minus 1, up to 0, up to plus 1, down to 0. See, it just becomes rote, okay? If you got your interval right, which is a quarter of your period, it's always going to be that way. Going in the opposite direction, goes down to your amplitude, minus 1, up to 0, up to plus 1, down to 0, down to minus 1. So here is how this one looks. I don't draw curves well. Okay, it just keeps on trucking like that. Now, if you pay attention to it, remember the sign used to be quarter pies. So it would go up, 0, down, and back here. So you see this is a vertical stretch. I mean a horizontal stretch. No vertical change because your amplitude is 1. But a horizontal stretch here because your B was less than 1. Okay. Positive but less than 1. Okay? Well, that's how I think it should look. They probably drew in your sine function, and we can do that. What color you want me to draw in your sine function? Pick a color. Green. Okay. It started at 0, but it went up to 1 at pi halves, and then 0, then minus 1, 0, 1, 0, minus 1, 0, 1, 0, minus 1, 0. Okay, so it would have looked like this. And on the other side the same. So you see the black curve is a horizontal stretch twice because your period was, your B was 1/2. Okay. I don't know if that's helpful or not. I think they're going to show it. So that's why I did it. Let's see if they show it. All right, to erase? Yay? Okay. So let's see. Amplitude is 1, see? They don't list A, B, C. I do. Amplitude is 1. Moreover, because the B is 1/2, the period becomes 2 pi over B, 2 pi divided by 1/2, which is 4 pi. Okay, next thing I do, divide that period by 4. They don't. Okay? Well, they sort of do. No, I don't know. Now divide the period into 4 equal parts. So it'll be pi, 2 pi, 3 pi. So they did the same thing. That gives you your key points, your starting point, max, intercept, min, intercept, max, intercept, min, intercept, max. Those are your key points. They like to list them out this way. I just do them on the graph. I mean, it just seems like an extra step here. Okay. And here's the graph. Now, they do show the basic function, and then this is your expanded function. Period is stretched to 4 pi rather than 2 pi for the basic. Does that make sense? Looks a lot like ours, maybe not quite as pretty as ours. But, okay. Make sense?
So
yeah.
This stretch there's the 4 pi. That's the same one as we got?
Yeah, we had the period of 4 pi. I think it's already destroyed now. The normal period was 2 pi. We just stretched it to 4. If you remember. Amplitude stayed the same. All right, good deal. Any other questions on that? Okay. Next, they're moving to translations of sines and cosines. How are we doing time-wise? What's that?
5 minutes.
5 minutes. Okay. Let's get at least the verbiage done. We probably won't get the example done. Okay. The next thing we do, we had an A there that is related to the amplitude. We had the B, which is related to the period. Now we're going to introduce the C. I don't like the way they do it because I'm used to doing it in a physics sense, and this is an awkward way to express C. But they're doing it, so get used to it, okay? It looks pretty simple, but it is really awkward, okay? So we're going to introduce a C, and what this is a horizontal, because you're changing the X, horizontal shift, okay? Translation, right or left, okay? So Bx minus C, y is equal to A cosine Bx minus C. Creates a horizontal translation or a shift in the basic sine or cosine curves. Comparing y is equal to A sine Bx with y is equal to a sine bx minus c, you find that the graph of y is equal to a sine bx minus c completes one cycle from bx minus c equals 0 to bx minus c is equal to 2 pi. Now that is true, but again, I find this a fairly awkward way of doing it. But one period happens when what's inside here goes from 0 to 2 pi. Whatever's inside there. Okay. Now they're going to incorporate the b and the c at the same time. And since we don't have much time, let's just see what they do next. Yeah, by solving for x then, and what they just said, because they said bx minus c was 0 to 2 pi, solving for x, and this is, they haven't done it neatly, but they do it, then what you get is you, it was, all right. Let me go back and write what they should have written here. Okay, let me get out of green back to black. Okay, what they had, 0 is less than or equal to bx minus c is less than or equal to 2 pi. That's what they should have written. Okay, then they're going to add c to all three sides. Okay, and that will give c less than or equal to bx less than or equal to 2 pi, and then divide by b. Okay, and that will give you c over b less than or equal to x less than or equal to 2 pi over b. Okay, that's what they got. Okay, now one thing they did a little differently. Oh, I left off the plus c here over b. Okay. Because I added 2 pi to c, and then I forgot to add it. I added to 0, I forgot to add it to 2 pi. Okay, and that gives us this. Now again, that is a really awkward way to do this, I think. So that implies that the period of this is from 2 pi over b. Yeah, the period is 2 pi over b, exactly like what we had before, and the graph is shifted by an amount b over c over b. Okay, and that's called the phase shift. Okay, because here's the period, and there's the phase shift. Okay, c over b, meaning you're starting there rather than starting at 0. Or yeah, so this is a bit awkward. Now we're out of time now, right? Or do we have a minute, 2 more? Huh? 1 minute. Okay, here's how I like to do it. Okay, when you have this form, I like to do it this way. I like to write my basic y is equal to a sine b times x minus c. Okay, that makes more sense physically. C is now your phase shift, not c over b. Okay, and this is your period. I mean, affects the period. But you see, my c is not the same as theirs. Their c is my BC, you know, and in physics you'll wind up doing it more that way. But don't sweat it, it all works out the same. But when we get to doing them, I'll let you see. So the number c over b is their phase shift. The way I do it is just the number c is the phase shift. All right. So we'll begin next time. We're out of time now, right? Huh? Okay. So we'll start next time with this slide here, graphs of sine and cosine functions, as if we haven't been doing that already. But before we go, let me do 2 things. Number 1, give you some homework exercises. I think you can do any of the odds 5 through 11. They're all at Calc Chat. 7's at Calc View. I think you can probably do all of 13 through 20. No, I'm sorry. Do some of the odds 13 to 19. They're all at Calc Chat, and then do either 21 or 23. They're both at Calc Chat. Okay? Then do any of the do 13 through 15, because we haven't done the phase shift. We talked about it, but we didn't do it. So just do that. All right. Now, let me get to anyone else who came in did not get test 1. Just quick chicken. Just making sure you're all stored so you can get to your next class. Okay. All right. It's pretty long and involved. You have at least a week to do it. But if you need more time, just be sure you get it in before we finish 4.8, because I'll be giving the second test by then, and you need to make sure you've got the first test in by then. Okay? Good deal. Any questions? You too. Thanks.